Good afternoon, all. Myself is Vigneshwari, Assistant Professor in the Department of Electronics and Communication Engineering from SNS College of Technology, Coimbatore. So, kindly watch my previous videos on microcontroller and application on the topic timer and instruction pipeline and also pick interrupt. Today, we are going to see a session on MSP 430. So, this comes under the unit pick timer, serial port, and interrupt. What is that MSP 430? So MSP 430 is a mixed signal processor of a 430 family where it could handle both analog as well as digital data. That is, this has been efficiently used for sensor based low power application or battery operated low power application. And the topic for discussion is today architectures and features, introduction to MSP 430, memory organization, clock system and power modes. So the concept remains the same across the families of microcontroller, whether it is a PIC or MSP 430. What changes is how efficiently the microcontroller operates, especially when power consumption becomes a critical part. So let's get started. MSP 430 is a 16-bit RISC-based microcontroller developed by Texas Instrument. So its biggest strength is ultra low power consumption without compromising its performance. So that is why MSP 430 is widely used in wearable devices, medical instruments, wireless sensors, portable electronics. So any system that must run for months or years on a battery often uses MSP 430. And the key features is it uses a 16-bit RISC architecture, which means the instructions are simple and efficient. Second, it operates at very low voltage, that is from 1.8 to 3.6 volt, which directly reduces the power consumption. It also supports clock speeds up to 25 MHz, multiple low power modes, and has on chip flash and RAM. And this is MSP 430 architecture. At the center, it is the 16-bit CPU which executes the instruction efficiently. The memory system includes flash memory for program and RAM, random access memory for data. The clock system controls how fast different parts of the controller run. Input output port, it allows the communication with the outside world, and timers generate precise delays and PWM signals. So every block is designed with energy efficiency. Memory organization. Memory organization in MSP 430 is very systematic. So RAM is used for temporary data storage and variable. Flash memory stores the non-volatile memory, program memory, which we say. So it stores the program permanently. Next, the peripheral registers, it control the hardware module like timers and analog to digital converters. Special function registers, or we say it as an SFRs register, it manage the interrupt and the system flag. So this clear separation makes the programming easier and more organized. Clock system and power modes. So this is where MSP 430 it truly stands out. So MSP 430 it uses multiple clock, main clock for CPU operation, sub-main clock for peripherals, auxiliary clock for low frequency operation. Based on the application need, MSP 430 can enter low power mode from LPM0 to LPM4. So in these modes, unused module are turned off, saving energy while still monitoring event like sensors or inputs. Input and output port. MSP 430 are very flexible. Each pin can be configured as an input or output or interrupt enabled input. Special registers like PXDIR, PXIN PXOUT and PXREN control the ports. So this makes MSP430 ideal for event-driven system where the microcontroller wakes up only when it is being needed. Next comes with the instruction pipeline. MSP430 support maskable and the non-maskable interrupt with a vector interrupt system. The CPU jump directly to the current interrupt routine, resulting in the faster response time. Interrupts can be generated from timer, ADC, IO ports, and communication modules. This event-driven approach further reduces the power consumption. And let's summarize. MSP430 is a 16-bit low-power microcontroller and it has been designed for battery-powered embedded system, uses efficient architecture, multiple clocks and power modes, offers flexible I/O and fast interrupt handling. And this is a design used for energy efficient embedded application. Thank you.